So a quick review on how to solve a quadratic equation using the quadratic formula. And obviously the quadratic formula is given here. If you don't have it memorized, you need to have it memorized or have it referenced, such as some background knowledge there that we're going through. And of course, when we talk about all these letters A, B's, and C's, we just mean the coefficients in standard form of a quadratic. So A is the number before x squared, B is the number before x, and C is your constant term if it is equal to 0. So to use the quadratic formula, there's really only one requirement. It just has to be equal to 0. And that's a benefit of the quadratic formula. You can always use this method. So it's a benefit, but sometimes it's not the most efficient method. Sometimes it's really slow, but at least it gives us an answer. So our only requirement is it's got to be equal to 0. So if we're supposed to solve this one using the quadratic formula, the only requirement we have is that it is equal to 0. And this one it is. So before we start doing anything, we should just make a list of our A value. So the number before x squared is 1, the number before x is 4, and the constant term is a negative 12. If you need to, put in your little term separators between the plus and the minus sign so we can see our A value, our B value, and our C value. So the quadratic formula tells us to find the answer for x. If it's equal to 0, we would take the opposite of B. So right now B is 4, so the opposite of B is negative 4. Then we have the plus or minus sign. We're going to take the square root of some giant thing. So B squared minus 4 times the A value times the C value, taking the square root of all that. And all of this should be divided by 2 times the value of A, which is 1. So what we're going to do is we're going to do a lot of simplifying before we do anything. So I'm going to simplify under the square root. So this is, what is this number? It's 16 plus 48. And if you absolutely needed a calculator to do that, that would be fine too. So once we simplify under the square root, we realize that we get the square root of 64. 16 plus 48 is 64, and then 2 times 1 is just 2. So we're going to continue simplifying, so I'm just going to simplify the square root because I know what the square root of 64 is, which is just 8 over 2. Now when I'm here, this is not my final answer. I cannot leave it like this. I need to go simplify my answer. So when we get the answer, x is equal to negative 4 plus or minus 8 over 2. We need to break that into two smaller equations. So it means x could equal negative 4 plus 8 divided by 2. So we know that's just 4 over 2, which is just equal to 2. Or it could mean that x was equal to negative 4 minus 8 divided by 2, which is negative 12 over 2, which is negative 6. So you can see when I have this plus or minus, one of them I use the plus sign, and the other I use the minus to get my two separate answers. So we're solving this one with the quadratic equation. When we look at a requirement, it's not equal to 0. So the first thing we'd have to do here is get it equal to 0. So it's easiest to get it equal to 0 by subtracting 12 from both sides. So we rewrite it, x squared plus 7x minus 12 is equal to 0. It helps you put in your term separators between the plus and the minus sign, so you can make a quick list of what your A is. So A is equal to 1, the number before x is 7, and the constant is just negative 12. So then what we're going to do here is just go ahead and fill in our quadratic formula. So the answer for x will equal the opposite of b, so the opposite of 7, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the value of a. So when we start to simplify, we're going to simplify under that square root first. So we get 49 plus 48 when we simplify that, which is actually the square root of 97. And then this is all going to be divided by 2. Now on this one, again, we want to simplify our answer as much as we can. I don't know what the square root of 97 is, and I can't simplify it anymore. 97 doesn't have any perfect square factors, so I just need to write my answer separately. So I'm saying x could equal negative 7 plus the square root of 97, all divided by 2. Or the other answer, x could have been negative 7 minus the square root of 97, over 2. We get both of those answers there. If we were to solve this one by the quadratic equation or formula, what we can see is it is equal to 0 already. So unlike other methods, we don't care what the leading coefficient is. It doesn't need to be positive, negative, or 1 or not. So once it's equal to 0, we make a quick inventory of what our a value is. So the number before x squared is negative 2. The number before x is negative 5. And the number at the end is negative 3. Again, if needed, kind of put your term separators in before the plus or minus. So we're going to set up our quadratic formula here, and it says to get the value of x, it's simply the opposite of b. So right now b is a negative 5. So the opposite of a negative 5 is actually a positive 5. And we have our plus or minus sign. We're going to take the square root of something. So what is b? Well, b is negative 5. So we have to square that. Notice the use of parentheses. And we're going to subtract 4 times a times c. And then we're going to divide all of it by 2 times the value of a. Now notice how I'm using a lot of parentheses here so I can keep track of my signs. So if I was going to simplify this, I can see I get the 5 and the plus or the minus. So I always simplify under the square root first. So what is negative 5 squared? Well, that's a positive 25. And we look here, I have a negative, and another negative. So I know my answer is going to be a negative. So 4 times 2 times 3 is 24. So simplifying, we get x is equal to 5 plus or minus the square root of 1, all divided by negative 4. So to write that as two answers, x would equal 5 plus 1 over negative 4, in which case we get 6 over negative 4, which is negative 3/2. Or our other answer could have been x was equal to 5 minus 1 over negative 4, which would equal 4 over negative 4, which just equals negative 1. One last example, if I was going to solve this using the quadratic formula, the first thing I need is that it needs to be equal to 0, and it's not. So it doesn't matter what side I get equal to 0. It's easier for me to get this side equal to 0 because there's less terms to undo than this side. So I'm simply going to subtract 2 x's from both sides and rewrite it. Once it's equal to 0, I can make inventory of my a value, my b value, and my c value, and set up my quadratic formula. So x will equal the opposite of b. So right now b is negative 2, so its opposite is a positive 2, plus or minus the square root of something, and that's going to be b squared, so that's negative 2 squared, minus 4 times a times c. And that's all going to be divided by 2 times a, which in our case is 1. Now with this one we start to simplify. I'm just going to simplify under the square root first. Always do that in 2 steps. So what is this expression equal to? Well, negative 2 times negative 2 is 4. 4 times 1 times 7 is 28. And there's only one negative, so it's going to be minus 28 all over 2. So as we simplify this in the corner here, so x would equal 2 plus or minus the square root of negative 24 all over 2. Now the problem with this one is we can't take the square root of a negative number. So no matter what we do with the 2 on top or the 2 on the bottom, since this is not a real number, we won't be able to do anything with our answer. So if we get a negative under the square root, this simply has no real solutions.